So we're doing the properties of logarithms today, and we will be solving some logarithm problems today. The product property, multiplication converts to addition. Quotient, division converts to subtraction. Power property, powers convert to a multiplier up front. These are what those are saying. These are your log properties, and I have them written over on the board over here because we're going to be using them today. And these rules go in both directions. They go in both directions. And which one you want to use depends upon the situation you're in. Frankly, for most of the work that you are going to do in here, you're going to want to go from the addition to the multiplication. You're going to want to go from several logarithms to a single logarithm. That's mostly what you guys are going to want to do. My calculus students, on the other hand, is completely opposite. They want to take one complex logarithm, change it down into several simple logarithms. It makes it much easier for them to do the work that they need to do. It's just the nature of the beast. But these rules are just like the rules for exponents. You need to know them. You need to be able to use them. You need to have them down. Okay? You can't do some of the things we need to do if you don't have these rules down. Now, when we were solving exponentials the other day, first started doing logarithms and exponentials, we started solving them using the loop method. That was the first of 4 methods we're going to learn. This is the second one, canceling the log on both sides. If you have an equation that is a logarithmic equation, and you can simplify it so you have the logarithm of something equal to the logarithm of something, those two somethings have to be the same. If you're taking the log of some number and the log of some number, and those two numbers, the logs of those numbers are the same, that means those numbers have to be the same. So if you end up getting it singled down to a logarithm equal to a logarithm, you can cancel the logarithms on each side and just set the two things you're taking the logs of equal. That is an extremely useful skill. How do you get one logarithm on each side? Using the properties of logarithms to combine things up to get a log on one side. So it's all combined to one logarithm. That's what the skills required are. Okay, that's what you need to be able to do. And we're going to do a lot of solving in here today. My apologies at this point. Once again, in this section, there's a page missing from your notes. Just like the other day, my apologies. I think what happened is a couple of papers got stuck together. It happens occasionally. It's rare that it happens more than once in a packet. I did look at the following one. I think we're all good after this one, but there is one page missing in here. Once again, my apologies. You'll just have to write it down and copy the problems down somewhere and work them out, because we're still going to do them. Okay. So let's work to our first set of examples here. You want to expand using the properties of logarithms. Once again, I wrote them over here, so I've got them in front of me. Easiest thing to remember, anything that's multiplied becomes addition. Anything that's divided becomes subtraction. That's the first thing that you do, and then after we do those separations, then we apply the power rule. Okay, but the first thing is anything that's multiplied is addition. Anything that is divided becomes subtraction. That's the first step we have. So in the first problem, I have log base 7 of 8xy. That's the log base 7 of 8 plus the log base 7 of x plus the log base 7 of y. Easy enough.
Would it m just be 8x, or is x a different variable? Like, wouldn't it just be log base 7 plus, 8x plus log base 7y?
Because I want to split everything up.
Okay.
Because 8x is 8 times x times y, right? Yeah, everything. Okay, next one, my first step is still the same thing. This is log base 3 of x squared plus log base 3 of y. So that's the first step you do. Now, I have an exponent on this one. I want to apply the power rule. The power rule basically says any exponent you have, you can bring right down in front of the logarithm. So this 2 that I have here comes right down in front. So instead of log base 3 of x squared, I have 2 log base 3 of x plus log base 3 of y. Power rule says bring that power down out in front. So if I look at the next one, okay, this one's got division. Log base 6 of x to the 5th minus log base 6 of y. And now I want to bring my power down out in front. So I get 5 log base 6 of x minus log base 6 of y. On this last one, I have multiplication and division. Anything that's in my numerator, I've got a combined thing here. Anything that's in my numerator is addition. Anything that's in my denominator is subtraction. That's it. So I have log base 8 of 2 plus log base 8 of c cubed minus log base 8 of d to the 4th, and then bring your exponents in front. Log base 8 of 2 plus 3 log base 8 of c minus 4 log base 8 of d. It's not that hard, but it's important to be able to do. Sometimes you want to split them up. Sometimes it's easier to work with these than it is to work with other ones. It all depends upon the situation. Your turn to do those. And do you have, is this the page you're missing? Yeah, okay. So I'm going to scroll up a little bit here. So it's the same thing. There, that gives you all the problems in the last one. That's an important one to get written down. Do those. Copy them down anywhere you can. Margins, that works fine. Okay, wherever you can find room, get them written down. Okay, so all the answers were all there. Who cares? All the answers are there. Phil, my bad for not getting the recording, but the one that's important is the one that it will be recorded here for the sound. Once again, you absolutely have to have, you cannot do it as it stands. You cannot simplify this in radical form. You must rewrite it as an exponential before you do it. So your first step is to rewrite it as log base 5 of a over b to the 1/2 power. Now you do have some options for me here. The one that I actually prefer is you distribute the 1/2 power because you can distribute power over division. So this is log base 5 of a to the 1/2 over b to the 1/2. Okay, because exponents distribute across division and multiplication, not across addition or subtraction, but across multiplication and division. Which gives me the log base 5 of a to the 1/2 minus log base 5 of b to the 1/2. And then bring the power down out in front. 1/2 log base 5 of a minus 1/2 log base 5 of b. Now, there is another option for solving this one. At this point here, you can instead bring the 1/2 down at that point in front of everything, and then split your logarithm into 2. So you have 1/2 times the two things. So you would have 1/2 log base 5 of A over B, and that would give you 1/2 times log base 5 of A minus log base 5 of B. And these two here are equivalent answers. So either one would work. But the important thing is you absolutely have to rewrite your radical as an exponent, or you cannot do this. You can't simplify it in radical form. There's actually not a whole lot of things you can do to stuff in radical form. You put them in exponential form, it's so much easier to work with. Okay. You do not have these problems either. My apologies. Take a moment, write them down. Get over it. Let's do these. Okay. Ladies, gentlemen, listen. So let's do these ones here. Your first step is actually to move any numbers in front, make them exponents. So I have a 5 in front here. That means I have y to the 5th. Just bring that number up. Okay, that's your first step. And then anything that's an addition, you multiply. So this becomes log base 6 of xy to the 5th. Next one, same thing. Bring up the 2. Bring up the 3. Now I have subtraction. So I have division. Log base 8, z squared over x cubed. Gentlemen, thank you. Okay. Bunch of stuff on here. Same idea. Bring up the 3. Bring up the 5. And then this is all addition. Log base 5 of 6a cubed b to the 5th. Now you'll notice on the next one, I have it grouped. So the stuff that's in front goes in my numerator, it's addition. The one that's by itself, the subtraction, goes in the denominator. I bring the 2 up. Log base 8 of xy over z squared. And then the last one, once again, the subtraction is everything here subtracted. So that means everything that's in there goes to my denominator. This is the same as if I had minus 6. Actually, I write it above. If I had minus 6 log base 2 of b minus 5 log base 2 of d, those would still go in the denominator anyways, because they would both be subtraction. Those two are equivalent. So the first one, bring the 4 up, bring the 6 up, bring the 5 up, and then this goes in my numerator, log base 2 of a c to the 4th over b to the 6th, d to the 5th. Guys, stop. Questions on this? It's not that hard. You will actually be doing more of this than splitting it up. But you need to be able to do both because it will both be on the test. Okay, do these, and you do have these in your notes. Ladies, gentlemen, focus, eyes up front. So, once again, bring the powers up first. Then I have log base 3 of c divided by d to the 4th. That should all be part of the log. Bring up the 2, bring up the 3, bring up the 5. That's addition, so it's all multiplying. That's easy. Log base 9 of h squared k cubed g to the 5th. This next one here, bring up the 9. Bring up the 6. It's addition here, subtraction there. So it's log base 5 of u to the 9th v over w to the 6th. This one, bring up the 5 first. I have 1/3 log base 2 of n over m to the 5th. Combine up the logarithms first because the 1/3 is on the parentheses outside. Now I can take that 1/3 and bring it up. So I get log base 2 of n over m to the 5th to the 1/3 power. Going back to last chapter, 1/3 power means that I'm doing what? Cube root. So this is the log base 2 of the cube root of n over m to the 5th. That's what you want for your final answer. Questions? Okay, next one, example problem number 3. The key to solving all of these problems here, the key to solving these problems here on this page and the next one is the fact that the log base x of x is 1. If the base of the logarithm and the number I'm taking the logarithm of are the same, that answer is 1. Log base 3 of 3 is 1. Log base 10 of 10 is 1. Log base 259 of 259 is 1. So if the base of the logarithm on the same number, that's 1. Okay? That will make it so you can do every single one of these problems. What I have to do is I have to apply these rules to simplify it up. So the first one, log base 2 of 8 minus log base 2 of 4. Now I can simplify it first and deal with it then, but realistically, just divide them out. This is log base 2 of 8 divided by 4, which is log base 2 of 2. And log base 2 of 2 is 1. The next one. Log base 2 of 160 divided by 5. Log base 2 of 32. Thank you, 32. Okay, now I have an issue. I don't have log base 2 of 2. I have log base 2 of 32. But 32 is 2 to the 5th power. So this is log base 2 of 2 to the 5th. What can I do to my power? Bring it out in front. So I have 5 times the log base 2 of 2, which is 5 times 1, which is 5. No, you multiply. You don't divide. Why would I divide the other one? Multiplying, right? Because it's addition.
Oh.
So on this one, log base 6 of 27 times 8, which is log base 6 of 216. Why is it 216? Because 216 is 6 cubed. So this is log base 6 of 6 cubed. So 216 is. Bring down the 3. 3 log base 6 of 6. And the log base 6 of 6 is 1. So I get 1 times 3, which is 3. And the last one. Log base 7 of 14 divided by 2, which is log base 7 of 7, which is 1. Piece of cake. But the rules of logarithms allow you to put this into a form that you can solve it with.
I didn't answer that on C.
It's not, because the C would be going the other way. So 3. I know the kids can read your numbers, can't read letters either. Okay.
Surprised it made this far.
Yeah, you and me both. I'm sorry.
Okay.
That's being mean. Okay, your turn. So let's do this. Okay, so the first one, log base 3 of 18 divided by 6. Guys, thank you. Log base 3 of 3, which is 1. This is log base 4 of 32 divided by 2, which is log base 4 of 16, which is log base 4 of 4 squared, which is 2 log base 4. Okay, ladies, gentlemen, thank you. 2 log base 4 of 4, which is 2. This next one here, you need to bring the exponents up for, yes. You're right, it's multiplication, my bad, thank you. So, changes, my bad. So that would be 64, which is log base 4 of 4 cubed, which is 3 log base 4 of 4, which is 3. My bad. This one you have to bring the power up first. So I have log base 2 of 16 to the 1/2 minus log base 2 of 2. 16 to the 1/2. 1/2 power is square root. What's the square root of 16? 4. So this is log base 2 of 4 minus log base 2 of 2. Now, you have options here. I can take the log base 2 of 2, and this is what? 1. And then I can simplify the log base 2 of 4, and then get from that, take whatever I get from that and subtract 1. Or I can combine them up now. The numbers are easy enough to deal with. I go ahead and divide and make it 1 logarithm. So this is log base 4 minus, or 4 over 2. Log base 2 of 4 divided by 2, which is log base 2 of 2, which is 1 for my final answer. This one, bring your power up first. Log base 4 of 64 plus log base 4 of 2 squared, which is log base 4 of 64 plus log base 4 of 4. Now this one I would go ahead and do it now. Because what is the log base 4 of 64? 3, because we just got done doing that problem. So this is 3 plus 1, which gives me 4. Or I could multiply them and figure out and figure it out from there. Either way would be okay. But this is one where, hey, I've got 64. That's already a big number. It would get bigger. I don't want to do that. I've already solved for the log base 4 of 64. I'll use that answer. Okay, no reason not to use something you already know. Okay, these are solving. So the first one, and we have a new method of solving. The new method of solving is log on both sides. I have the logarithm log base 2 of 10x equals the log base 2 of 3x minus 14. I'm taking the log of something and the log of something. If those two things are equal, that means those two things need to be equal. If the logarithms of the same, if the logarithm of two things are equal, and it's the same log base, that means those two objects I'm taking the logs of have to be the same. That means 10x equals 3x minus 14. And I have to solve that. Subtract 3x, and I get 7x equals negative 14. Divide by 7, x equals negative 2. But we're not going to do that. You're not allowed to take logarithms of negative numbers. So if I take negative 2 and plug it back in the original problem, what's going to happen? I get negative 20, it doesn't work.
It doesn't work. Why not?
Because 2 times itself, no matter how many times I multiply 2 times itself, I will never get a negative number. So I can't take the logarithm of a negative number. But I'm not going to worry about that here. It works for solving the problem, for solving for x, but it doesn't work in the original problem. So this would be considered an extraneous solution. We are not checking those on these. Okay, but technically it is an extraneous solution. We're not checking those on these. That would be the answer you would give me. Okay. This one here. I don't have a log equal to a log. I have 2 times a log equal to a log, which means that I need to bring this power up here, and then I can set the 2 sides equal to each other. X plus 2 squared equals 3x plus 16. Because I brought the power up, and then I had log equal to a log. FOIL. X squared plus 4x plus 4 equals 3x plus 16. What do I need to do next? What do you have to do to solve a quadratic? It has to be equal to 0. Subtract 3x. Subtract 16. X squared plus x minus 12 equals 0. X plus 4, x minus 3 is equal to 0, x equals negative 4, x equals 3. Solving your quadratic. Next one. I don't have a log equals a single log. I need to combine these into one logarithm. I cannot cancel logs like this. I have to have equal to a single log. So I need to combine these up. So I get log base 9 of 8 equals log base 9 of x over x minus 2. You have to combine them up. You cannot cancel logs unless it's a log equal to a log. Now I can cancel. 8 equals x over x minus 2. And how do I solve this, Mr. Orris? I hear some of you cry.
How do you solve this?
Thank you. Multiply both sides by the denominator. So you get 8x minus 16 equals x. Subtract 8x from both sides. I'm running out of room here. My apologies. And you get negative 16 equals negative 7x. Divide by negative 7x equals 16 over 7. Yeah, just get rid of the denominator. Multiply both sides by the denominator, not a problem. Now, I got a serious issue on this one, comparatively speaking. I do not have a log on both sides. And if I added log of 4 to the other side, I still wouldn't have that. Combine those up into one logarithm. Log base 10 of x over 4 equals 3. Do I have a log on both sides? No, so I can't cancel the logarithm on both sides. I need to loop it like we were doing the other day. Rewrite it as an exponential. What is the base of my logarithm when I don't have a number written down? Log base 10. This is a common logarithm. It's log base 10. This says that 10 to the third is equal to x over 4. What's 10 cubed? 1,000. What's 1,000 times 4?
4,000.
So x equals 4,000. Yeah, you can't cancel the logs on both sides. You don't have logs on both sides. And it has to be a logarithm of something, and only that. Oh, you're way ahead of me. I hear the papers turning. Do these problems. All right, let's do these. So you have time for your quiz.
Oh boy.
Okay, first one, log of two things. 7x equals 2x minus 15. Subtract 2x, 5x equals negative 15. X equals negative 3. This one, bring the 2 up first. So you get x plus 1 squared equals negative 2x plus 6. So x squared plus 2x plus 1 equals negative 2x plus 6. Add 2x, subtract 6. You get x squared plus 4x minus 5 equals 0. Factors of 5 are 1 and 5. One's positive, one's negative. X plus 5, x minus 1 equals 0. X equals 1, x equals negative 5. This one here, you need to combine it up in one log first. First thing you do is bring up the 2. And remember, the whole 3x is squared, not just the x. The whole thing gets that power. So that gives me the log of 3x squared over 9 equals 1, which 3x squared is 9x squared. So this is actually the log of x squared is equal to 1. Okay. Loop it, and you end up with 10 to the first is equal to x squared. Square root both sides. X equals the square root of 10. Next one, combine them up into 1. Log base 8 of 2x over 5 equals 1. That means 2x over 5 equals 8 to the first, which is 8. Multiply both sides by 5. 2x equals 40. Divide by 2. X equals 20. Questions? Okay.